Okay, my dear. Cells in series and parallel, if you want to understand, then it is very important for us to understand what is a simple cell, how does it behave, and if the same cells are connected in series, how they are going to behave. So this is a small internal resistance, external resistance, EMF of a cell. This is a simple cell. Okay. Now here, the current is passing in this direction because current has to travel from positive to negative. Then what is the current across this simple cell here? A simple formula is I is equal to V by R according to Ohm's law. But here we write I is equal to V means E, and small r is nothing but, instead of R we can take R net resistance, net EMF by net resistance. So instead of taking V by R net, we will consider the formula for the current which is passing through the circuit is E by small r plus capital R. Hope you understood now what I am saying. This is going to be the formula for a simple circuit. Okay. Now just see, try to understand what is going to happen when you take a series of cells now. See, this is one cell having internal resistance, another cell having internal resistance, another cell having internal resistance, and like this. Cells are connected in series, and all these cells are connected to an external resistance capital R. Try to understand that each and every cell is having same EMF E only, and each and every cell is having internal resistance which is given as small r, which is combined to an external resistance which is taken as capital R. Now we have to find out what is the current passing through the simple circuit. Try to understand what is the current passing through the simple circuit. So for this, the simple logic we use, whatever the logic we are using for a simple circuit, which is written there here, the formula is this one. So here also, I in series connection, when cells, how many cells? N cells are connected in series having internal resistance R. Okay. So here, first of all, find out what is E series. Total EMF when they are connected in series is taken as E plus E and so on up to N times. This can be taken as ES is nothing but N into E. Hope you understood this one. Yes. Now R in series is taken as R plus R dash 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 N times. So R in series is nothing but N into small r. N into small r. ES is equal to N into small N into capital E. Hope you understood why I have written this one. See, for example, there are 20 students who are arranged in one row. Prayer 20 students. How many students are there means? Each and every student is having a height of 5 feet. What is the total height of the students when they are standing one above the other in series connection? How many students I told? 20 students. Each student is 5 feet. So how did you write that one? 20 into 5. Just multiplying with total number and height of each and every person. Similarly, you are multiplying N means N into E, series connection N into R. That's it. So the basic formula is not going to change here. This is going to be the basic formula for all the cells which are connected. Then what is the series connection? When cells are in series, what is the current passing through the circuit which are having n number of cells? It is very simple that you just write the same formula, but instead of E, you write ES, instead of R, you write RS, and instead of capital R, the same capital R you write here. Understood what I am saying? Then the final step you are going to write is I in series is nothing but N into E divided by RS in series is taken as N into R plus capital R. This is going to be the formula for your series connection. Understood what I am saying now? For example, internal resistance of each cell is 1 ohm. External resistance of the cell is 100 ohms. Okay. So how many cells are there? 100 cells are there which are connected in series, and the EMF of each cell is, for example, 10 volts. Hope you understood what I'm saying now. A simple example I am saying now. 100 cells are connected in series. Each and every cell is having a EMF of 10 volts. Internal resistance is 1 ohm. External resistance is 100 ohms. And what is the current passing through the circuit? The simple logic is 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 nothing but 100 into 10 by N into R, 100 into 1 plus again 100 here. Okay. So R is also 100, and 1 ohm into 100 cells, N into 100 is nothing but 100. Therefore, IS is going to be how much? 1000 divided by 200 is going to be how much? 5 amperes of current is passing through the circuit. We have solved the problem. A simple problem. Hope you understood what I am saying now. Is it okay? So let us go for the next case. Let us go for the next case, which is called as series connection. The parallel connection we shall discuss. So let us keep aside for an idea what the simple cell is going to behave like. This is small r, capital R, this is I, and if you want to find out the current passing, the current passing through the circuit, which is always traveling from positive terminal to negative terminal, higher potential to lower potential. Okay, so therefore I is equal to E net by R net, where E net is going to be single E and R net is going to be total resistance, that is taken as small r plus capital R. This is the simple basic formula. How can you apply this formula for a parallel connection now? For example, I have taken a simple cell having internal resistance R, another simple cell having internal resistance R, and like this. So how many cells are there? For example, like this, n cells. N cells are connected in parallel, and the total circuit is again connected to the external resistance R, which is called as capital R. Okay, so here let us see the current is passing in this way, because each and every EMF cell is having a current some I. So all these currents move in the from positive terminal to negative terminal, and the I parallel is going in this direction now. Okay, hope you understood. So total cells are connected in parallel with a external resistance which is called as capital R. Now, how are you going to find out what is going to be the total net current passing through this circuit? Okay. See here now. See, the basic formula for current is that one. Now, I parallel is going to be E parallel, try to understand, R parallel plus capital R. See here. So each and every cell is having an EMF of E, same EMF, and even internal resistance of the cells are also going to be same. Then what is the net EMF when they are connected in parallel? Okay. See, when all the cells having 10 volts are connected in parallel, then what is the total net EMF? See, net EMF is also going to be 10 volts only. We are not going to add all the 10s here. I'll give a best example. When 100 students of same height, 5 feet, are standing on the ground, one after the other, which is called as parallel connection, not one above the other, which is called as series connection. When all the students are standing one beside the other, and if I ask you what is the total height, what is the maximum height of the student, means if you tell the height of one student, that's enough. Am I right or not? One student 5 feet means okay, that is going to be the maximum because same heights. Hope you understood now. ఒకటి హైట్ చెప్తే చాలు కదా, ఇక్కడ కూడా అంతే. సో E parallel means you just write E parallel అంటే just one EMF if you consider, that's enough. But what about the R parallel here? See, R parallel, if you want to find out, 1 by R parallel is equal to 1 by R plus 1 by R plus 1 by R, because it is a parallel connection. 1 by R net is equal to 1 by R1 plus 1 by R2 plus 1 by R1, and this is going to be n times like this. So 1 by R parallel, 1 by R parallel is equal to n by R. N times kada, n into 1 by R is going to be n by R. Therefore, R parallel is going to be R by n. R parallel is going to be how much? R by n. And E parallel is going to be how much? Is going to be E. Hope you understood. You just do one thing, take this data and substitute here. Okay, take the data and substitute here. So finally, what is the result? Let us see. So I parallel connection. E parallel means you write just E, and R parallel means you write R by N plus capital R. R by N plus capital R. Then how are you going to simplify this data? How are you going to simplify this? Just here now, I will take this part of the derivation and I'll just try to simplify. I parallel is equal to E if you take separately and you take an LCM here, N as an LCM, then R plus N into R. Kada? Huh? So 1 into N is N into R if you do, this is going to be your problem. The final step is N into E is equal to R plus N into capital R. Okay, hope you understood what I am saying now. So this is going to be the final formula for I parallel, and what was the formula for I series connection? Just try to compare these two. I in series connection was N into E by N into small r plus capital R. Okay, is it okay? So this was in the series connection and this was the formula for parallel connection. Numerators are going to be same, but in the denominator, if you observe, N is multiplied to capital R in parallel connection, N is multiplied to small r in series connection. That's the simple difference. Hope you understood what I am saying now. So these formulas you have to remember now. It's a very important formula. You are going to solve the problems based on this now. Okay. Now let us use this formula here and try to find out the remaining things which are required now presently. So here, if you want to solve the problem of series and parallel combined together, then what happens? Let us see. See here, one cell, internal resistance, one cell like this. How many? N cells. N in series connection. Okay. Now, what is going to happen? Let us see. Now, the total system is connected to an external resistance which is taken as capital R now. Okay. So just try to understand a simple way I will explain now. How many cells are there? N in series. And how many rows are this? How many this type of rows are there means M rows. ఇలాంటి M combinations are there. N are in series, M are in parallel. Hope you understood what I am saying now. So with this, by using these two equations, you can create a final equation now. What is that final equation you are going to create? Let us see. Okay. So here this is a combination of just series plus parallel both combined together. Here N parallel na. Instead of N parallel means M rows are there, no? So here a parallel combination, if you take M means you should get M into E by small r plus M into capital R in these combinations. Okay, only M cells are in parallel, and if it is a series connection, as N cells are in series, you will just write N into E by R plus N into capital R. Let us take this way. Instead of taking N, I have taken M in parallel. So series and parallel. If only parallel connection is there, this formula you have to apply. Only series connection is there, this formula you have to apply. But series and parallel combination means M is also there, N is also there in this case. N in series, M in parallel. Then here series plus parallel connection, if you join these two, then you will get N into M into E divided by, sorry, series లో series combination में n into small r plus capital R kada. Hope you understood now. So by joining these two, combining these two cases, finally you get n into m into capital E, because n in series, m rows are in parallel, and m into small r, because n is at the small r and m is at the capital R, m into capital R. This is your final formula for series and parallel connection. Let me explain once again here. See, this is the case where n cells are in series. Let us take the first case here, where n cells are in series. Then the final formula was this one: n into e by small n into small r plus capital R. Now, instead of taking n cells in parallel, if you take m cells in parallel, your final formula will become how much? What is your final formula here? M into capital E by R plus M into capital R. To show the difference, that n cells are in series, m cells are in parallel. M. So show the difference. So I have taken m because n is different. N may be 100 cells, like that. 50 rows, 50 cells are in parallel. Let us imagine m means 50 here. So I have taken series combination. If you take series as n and parallel as m, where in the series n is multiplied to internal resistance, in parallel m is multiplied to external resistance capital R. The combination of these two will create a new formula in which numerator should be having n and m into e divided by small r plus m into capital R. Hope you understood this one. Is it okay? So this is going to be the formula here now. So here you can solve one problem based on this now. Okay. So before going to that, so now you can solve this problem. Yes. See here, it's a very important question which was asked in AIMS. Once it was asked in AIMS. So I'll show you how to solve this problem. First of all, try to understand that electric eel is present in Amazon forest. Okay, and this is producing electric shocks. Understood? It can kill even a crocodile by its biological cells present in its body. Okay, so you can just see how this is going to behave.
एक मासूम मगरमच्छ ने सामने खड़ी इलेक्ट्रिक ईल पर हमला कर दिया। मगरमच्छ को इस बात का एहसास नहीं था कि वो हाई वोल्टेज बिजली के तार को काट रहा है। हमले के कुछ देर बाद ही इलेक्ट्रिक ईल ने जोरदार कट छोड़ा और मगरमच्छ कट लगने से बुरी तरह कांप उठा। मगरमच्छ के मरने के बाद अब ईल को ये सोचना पड़ा कि मगरमच्छ को कैसे बचा जाए। एक मासूम मगरमच्छ ने सामने खड़ी
అంత పవర్ఫుల్ షాక్స్ ఉంటాయి దాని లోపల. You just see even Komodo dragon also cannot hold the shocks. Chala powerful shock. It is just like holding your main main wire of your. So there are many examples where human beings also have died because of this. Okay.
किसने गुजरात इलेक्ट्रिक ईल के बारे में नहीं सुना है? इस आदमी ने अप्रत्याशित रूप से ईल को अपने जाल में फंसा लिया और उसे बहुत सावधानी से संभाला। लेकिन तभी अचानक एक लापरवाह बूढ़ा आदमी आया और पूरी जागरूकता के साथ इलेक्ट्रिक ईल को नंगे हाथों से पकड़ लिया। दोनों वह तुरंत चौंक गया और पानी में गिर गया। वह आदमी उसकी मदद के लिए दौड़ा, लेकिन आभार के बजाय बूढ़ा आदमी गुस्से से भड़क उठा, मानो वह ईल से उसकी
ఏది ఇదా
ये है पानी में रहने वाली इलेक्ट्रिक एयर जो कि इतना ज्यादा करंट प्रोड्यूस करती है कि ये अपने एक झटके से ही इंसान को भी मार सकती है, क्योंकि ये मछली सिर्फ कुछ ही मिली सेकेंड के अंदर 860 वोल्ट तक की बिजली प्रोड्यूस कर सकती है, जो कि इतनी ज्यादा होती है कि ये अपने एक ही झटके से क्रोकोडाइल जैसे बड़े जानवर को सुला सकती है। लेकिन आखिर ये मछली इतना करंट बनाती कैसे है? तो देखो, इस मछली के अंदर मिलियंस ऑफ इलेक्ट्रोलाइटिक सेल्स प्रेजेंट होते हैं, और जब इस मछली को अपने आसपास कोई खतरा महसूस होता है तो इसका ब्रेन इन इलेक्ट्रोलाइटिक सेल्स को एक्टिव कर देता है, जिसके बाद ये सेल्स इतना ज्यादा करंट प्रोड्यूस करती है, और इस करंट की मदद से ये मछली शिकार भी करती है और दूसरे जानवरों को झटके भी देती है। ये पानी में रहने वाली इलेक्ट्रिक एयर जो
పట్టుకోలేదు అది చేస్తుంది పట్టుకుంటుంది, పట్టుకుంటే షాక్స్ చాలా భయంకరంగా వస్తుంది. సో దిస్ ఇస్ యువర్ క్లియర్ ఎలా ఉంటాయి సెల్స్ దాని లోపల అనేది ఒకసారి చూసుకుందాం. విల్ సాల్వ్ ది ప్రాబ్లమ్ నౌ బేస్డ్ ఆన్ దిస్. Okay, come on, solve this problem now, all of you. He's asking us to find out what is the current passing through this here. So to find out the current, you should know that N into M into E by N into, N into small r plus M into capital R here. So ఏమేమున్న N place లో electrical circuit ఇలా ఉంటుంది అనమాట. How many electroplates are there? Electroplates means cells which are present in this electric field. So what is N? ఒక రోలో 5000 అంటే N is going to be 5000. And how many rows are there? 100 rows. M means 100. Okay. So what is small r? See, small r is given as 0.25 ohms. And what is each and every cell producing how much volts? 0.515 volts. Okay. And external resistance of this is 500 ohms. Everything is with you now. So can you solve this problem now? Just come on, solve the problem and find out what is the current passing through this electric eel. Okay, now just here. The next topic here we are going to discuss is wrongly connected cells. Okay, just here. See totally how many cells are there? Totally n cells are present, in which m cells m cells are connected wrongly. మొత్తం n cells ఉన్నాయి, అందులో m cells are connected wrongly. So totally how many cells are there? Totally n cells out of, yeah. So how many are correctly connected now? How many are correctly connected? The remaining are correctly connected kada? See, these are correctly connected, positive and positive and negative, but these are wrongly connected, their direction has been changed. Then, so out of total n cells, if m are wrongly connected, then we write the correctly connected cells are n minus m. Am I right or not? So if you remove this m, these are correctly connected. See here. Now, and all these are in series connection. All these are in series connection. So therefore, E series is equal to n minus m are correctly connected. So we write it as positive, and their direction has been changed. How many cells are wrongly connected? M cells are connected wrongly. So we have to subtract them. M cells we have to subtract them. Then we will get ES is equal to this much. So if you simplify this one, E in series is equal to N into E minus M into E minus M into E will give you Ne minus 2Me, which is nothing but N minus 2M into E, which is in series connection, and that too wrongly connected case here. So here, as it is a series connection case, we can consider E in series by R in series plus capital R. Okay, so but as it is wrongly connected, we write this as N minus 2M into E divided by R in series is nothing but N into R plus capital R. So this is going to be the final formula for wrongly connected cells. Hope you understood this one. This is the formula for wrongly connected cells. Then there are some problems based on this. We have to discuss the problems based on this here. So let us solve these two problems regarding these cells connected here. So here all of you, the EMF of a cell is E, internal resistance of a cell is R, its terminals are connected to resistance capital R, the potential difference between the terminals of the cell is 12, so we can just take this. So how are you going to solve this problem? Let us see now. Okay, there is one cell E, internal resistance small r, it is connected to external resistance capital R. The potential difference between the terminals is how much? 12 volts. So what is the potential difference between the terminals? 12 volts here. Okay. And if R is here, the potential difference between the terminals is 12 volts when R is taken as 3 ohms, and 16 volts if R is taken as 8 ohms. Means you have to draw one more circuit of this type, which is having a E small r, and this is going to be the capital R, which is taken as here second case 8 ohms, and potential difference between these is going to be 16 volts. So potential difference he has given, and is asking us to find out what is the value of E and R. So that's why I told you the difference between E and V is completely different. So, but how do you find out now? How do you find out that one? So to understand that one, a simple logic you have to understand here, that there is an EMF of a cell E and external resistance R. Now here, then what is the potential difference across this circuit now? Potential difference is taken as V. All of us here. In this case, first of all, let us take discharging of a cell. Let us take the discharging of a cell here. So this cell is getting discharged, means from the cell current is passing like this. Cell is getting discharged, and the potential difference across these terminals of the cell is taken as V. All of you try to understand this one. Student, what I am going to say. See, difference between E and V. Discharging means, what is the meaning here? From inside the cell, current is coming outside. That means, in the case of discharging, E will be greater than V. When EMF is greater than external potential, then it is called as discharging. From inside, current is coming outside. So E is larger than potential difference. E is larger than potential difference. That means you have to consider E minus V. E is larger, that's why E minus V is equal to I into small r. But he is asking us to find out the potential here. And what is the formula for potential? Potential, if you take right side, you will get E minus I into R. Try to understand this one now. It's very important for you. And sometimes it is going to be very confusing. But I'll give you a beautiful idea so that you will never get a confusion here. See, now I will take another circuit having external resistance R, internal resistance E. Now this is the case of charging. Let us imagine it is the case of charging. External resistance you are going to charge it. Potential is connected here. This is the case of charging. Means external potential, if you apply to the cell, it gets charged, current flows in the opposite direction. Current will enter into the cell from higher potential to lower potential. If cell is only discharging, means current will come always from positive to negative. The direction of the current is also traveling from positive to negative. We are charging the cell, means you are applying a potential in such a way that cell gets charged. When cell gets charged, what does it mean? When cell is discharged, there is no EMF in the cell, then you need to charge it by applying the external potential. That means in this case, external potential is greater than E. Hope you understood what I am saying now. See, in the case of charging, external potential is greater than internal EMF of the cell, EMF of a cell. When it is case of discharging, it does it. What is that meaning? E is greater than V, so E is greater than V. E minus V is equal to IR. What is the current passing through this? E minus V is equal to IR. But here, V minus E is equal to I into small r. Then what is V here? V is equal to E plus IR in the case of charging. In the case of charging, and this is the case of discharging. Understood? Hope you understood the differences here now. Very important topic. Discharging means E is greater than V, so E minus V is equal to IR. Ohm's law only we are applying here. And in the case of charging here, charging means external potential is greater. Now you are charging the cell. Then what happens? V is greater than E. V minus E is equal to I into small r. So V is equal to E plus IR. There is a case of charging here, no? It's a case of charging here. So now you can solve this problem very easily. So here we are not applying any external potential to get charged here. Just cell is given. In general, all the cases, almost 99% cases will be discharging only. If it is a case of charging, he will mention in the question. If he is not mentioning anything regarding charging of a cell, means automatically it is going to discharge. Am I right or not? Is it okay what I am saying now? So this is a case of discharging. Then what are you going to write now? What is the current formula? Current is equal to net EMF by net resistance, which is small r plus capital R. Then what is the formula for potential according to Ohm's law? V is equal to I into capital R. Huh? Potential is equal to V into I into V is equal to I into capital R. That means V is equal to I means E by small r plus capital R into capital R. This is the formula for potential. Hope you understood here. Try to understand the concept first, then only you can solve the problem. Here, you know, current in the circuit which is trying to pass like this. Here also, the current is trying to pass from higher potential to lower potential like this. Then I is equal to E by small r plus capital R. That is the current here now. So potential according to what is the formula here? Ohm's law prakaram V is equal to IR. I means you write like this. Now you just see here how to solve this problem by using this this concept here. So I'll make you understand here now. Just see. See, the first case, 12 volts, it's given, am I right? 12 volts it is given. So 12 is equal to, E is not there, small r is also not there, capital R is 3, and here it is also going to be 3. So what do you understand from this? So 3 ones, 3 fours, 12. So E is equal to 4R plus 3 fours are 12. I think E is given in the first case. What is that? The potential difference across the terminal. That's it. So we are getting how much? E is equal to 4R plus 12. Hope you understood this one. 4R plus 4 is 12. Now let us take this as a case 1. And what is happening in the case 2 here? The same formula here. V is equal to V. V is how much here in this case? 16. E we don't know. And small r we don't know. But in the second case, capital R is taken as 8. And it is multiplied with again 8. My dear first year students, you might be feeling somewhat difficult. First time you are learning, but we have got plenty of time. Okay, why I am introducing this second year chapter for you know, so that తొందరగా కన్ఫ్యూజ్ అయిపో, తొందరగా క్లారిటీ తెచ్చుకో. నువ్వు సెకండ్ ఇయర్లో పోయి కన్ఫ్యూజ్ అయిపోయి సెకండ్ ఇయర్లో క్లారిటీ తెచ్చుకునే లోపల నీట్ ఎగ్జామ్ వస్తుంది. Now you have to spend one more long term. That's why try to confuse first, try to get confused faster, and try to get clarity also faster. This is first time now you are learning. These second year students already they know some of the basics. That's why for them it will be easy. For you it may be somewhat tough here. Those who are studying these all these things, what is this nonsense you might be thinking, but it's very simple. As you go on doing the problems, it becomes easy for you. So what do you understand from this now? Okay, so 8 1 times, 8 2 times, is it okay? So what are you going to get now? E is equal to how much? 2 into small r plus 2 into 8, that is going to be 16. Okay. So from this can you find out what is r first? It's very easy to find out r. Both LHS are same, so you can write 4r plus 12 is equal to 2r plus 16. So this comes to left side, becomes 4r minus 2r, which is going to be 16 minus 12. So this implies that this is going to be how much? This is going to be 2r. 16 minus 12 is going to be 4. So with this you got that R, internal resistance, is going to be 2 ohms. So once you get internal resistance as 2 ohms, the same internal resistance if you substitute here, 4 into 2 plus 12. So how much? 20 volts. Understood what I am saying now? Okay, so 20 volts. ఇక్కడ సబ్స్టిట్యూట్ చేస్తే కూడా అంతే రావాలి. వచ్చిందా సేమ్? Here also if you substitute, you should get the same 20 volts only. So what is R2? 2 to the 4. 4 plus 16 is 20. Both sides you are getting same 20. So we got, what did we get now? We get E, we get smaller also. Hope you are clear now. समझ में आया? Yes. So this is the concept here. Now let us solve the next problem. See, this is a question. When an unknown resistance is connected across the series combination of two identical cells, each of 18 volts, this is also 18, this is also 18 volts, and current through the resistance is 4 amperes. Current through the resistance means this is the resistance, capillary, and the answer is here. Current passing through this is 4 amperes. Okay, okay. I hope you understood now. When they are connected in parallel combination, when the two cells are connected in the parallel combination, then they are connected to again external resistance, which is called as capillary here. So here in this case, N is also 2. 2 cells, no? N equal to 2. Here M is also 2. So what is this here again? Same 18 volts. 18 volts is connected, smaller. Internal resistance is smaller here. Okay. So in the second case, if you observe, parallel combination, the current passing through this is going to be how much? 3 amperes it is given. Find the unknown resistance and internal resistance. He is asking us to find out what is capillary and also what is smaller. Okay. Hope you understood what I am saying now. So here, if this is a series combination, what is the formula for current here? The formula for current is nothing but E series. See, N into E by small n into capital small r plus capital R. This is a series combination formula. So therefore, I series it is given here 4 and N and N rendu. So 2 into how much? 2 into 18 divided by small n is 2 again. Any two resistors are in series now. So 2 into small r, we don't know what is that small r, it is not given. Even r is also not given. Okay, so let us see what's going to happen now. So how many times it will go? 2 ones, 2 twos, 2 ones, 2 nines. So 2 into small r plus capital R is equal to 9. We are getting the first equation now. Yes, this is equation number 1 from the first case. So what is the second case? It's a parallel combination, where in the parallel combination we write M into E by what is that? Small r plus M into capital R here. See, M is multiplied to capital R here, whereas N is multiplied to smaller here. That's the basic thing you have to understand. As two are in parallel, you have to consider M is equal to 2 here in this case. So what is the formula for parallel combination? I parallel is 3 amperes, it is given, and M is also 2 here, 2 into 18 divided by small r. We don't know what is small r, but we know M is 2 into capital R. Okay, so 3 1 times 3 6 are 18, 6 2 are 12. So how much you are getting? R plus 2R is going to be how much? 12. So this is going to be the second equation. Understood what I am saying? Now, second equation, can't we find out what is small r and capital R by using these two equations? You just do one thing. You make capital R coefficients of R you want to make equal. Again, you multiplied equation 2 with 2. Then how much you will get? 2R plus 4R is equal to 24. Multiplying 2 with this, so that coefficients will become same. Here don't need to multiply. 2R is already present plus capital R is there plus 9 is there. Subtract this one now. Subtract these two now. So how much you'll get now? 2R gets cancelled, plus 2R minus 2R, and this is going to be 3 into capital R. Here you can subtract here. Subtraction means 24 into 9 is going to be 15 here. So with this you'll understand that capital R is going to be 5 ohms. So once you understand what is capital R, can't you find out what is small r here by substituting this value in the second equation or first equation, what it will be? So small r enta telidu telusukovali. So capital R is 15. 2 into 15 2 into 5 kada, 2 into 5 is nothing but 10 here, which is nothing but 12. So this is 12 minus 10. Your internal resistance is going to be how much? 2 ohms. Is it clear? Understood what I am saying now? समझ में आ रहा बेटा? टेंशन नहीं लें, अभी टाइम है अपने पास. We can revise if you want. Okay, so this is going to be your problem. Okay, my dear, just see now. Okay, now find the potential